Good evening, students. Am I audible?
Yes, sir.
Students, am I audible?
Yes, sir.
Okay. So we have discussed the concepts, but we have not done the problems, right? So today I wanted to mainly concentrate on the problems part. So listen. Are you able to see my screen?
Yes, sir.
Okay. So first we'll start with the problems that are based on variation of G with altitude. Okay. So shall we get started with that? So first, make a note of these formulae that are there. So what are the two formulae that we have? Are you all done? See, look at the first question. Can you start solving this?
Sir, sir,
Yeah.
can you show the previous slide for just a second?
Sure. For you to write down the formula?
Yes, sir.
Write it down.
I'm done, sir. Thank you.
Yeah. So read this question and I want you all to try it out.
Should we take G as 9.8?
Sorry, I didn't get you.
Should we take G as 9.8?
I'm not sure. Is his voice low or am I hearing it low?
Yes, sir. Should we take G as 10 or 9.8?
Whatever it is, you tell me in terms of at what height from the surface of the earth will you take it as 10 itself.
Okay.
You first tell me in the general terms, what are you getting in terms of G, and then we'll see what is supposed to be done. So anybody with the answer?
That's 1,600.
Sorry, can you? I'm not able to hear you guys.
1,600.
1,600. That is one fourth of the
1/4 position.
radius of the earth. Is that what you're saying?
Yes.
Okay. Anyone else with another answer? Yeah. Am I audible now? Network issue, miss.
Recording in progress.
I'm expecting some answer. Okay, tell me how you are supposed to do.
So 60, I made it the point.
At what height from the surface of the earth will the value of G be reduced by 36% from the value at the surface? So what is the value of acceleration due to gravity at the surface? At the surface, it is going to be G. So let's say it has gone to this height, and what will be the value there? It is reduced by 36%. So how much will it be? 64 G by 100. Am I right? Yes or no?
Yes, sir.
Yes, sir.
G by 100. Then what is going to be the value of GH? What formula should I use here? G into
R square by R plus H.
R plus H. R plus H, the whole square. So G into, what should I substitute in the place of GH? It is 64G divided by 100. Am I right? So it is going to be R square divided by R plus H, the whole square. G and G will get cancelled. Then R divided by R plus H is equal to how much? It is 64 by 100, the whole power half, which is going to be 8 divided by 10. So what is the value of R? 10R is equal to 8R plus 8H, which implies 2R is equal to 8H, which implies H is equal to R by 4. So R by 4 is going to be 1600 kilometer. You're right. Good. Shall I proceed?
Yes, sir.
Good. Tell me. Solve this, 2 minutes time. So tell me the value of H in terms of radius of the earth. I'm not interested in knowing the exact value. So what should I write? GH is equal to G into R by R plus H, the whole square. Right. So what is the value of GH? The value of G is half of its value on the Earth's surface. So here it is going to be G by 2. is equal to G into R divided by R plus H the whole square. G and G will get cancelled, which implies R divided by R plus H is equal to 1 by root 2. So root 2R is equal to R plus H, which implies H is equal to root 2 minus 1 into R. Did you all get this answer?
Yes, sir.
Very good. Do this. Find the percentage decrease in the weight of the body when taken to a height of 32 kilometer above the surface of the earth. Radius of the earth is 6,400 kilometer. So can someone tell me how should I proceed?
Sir, first we can find G at height.
Okay. So you want to find G of H, GH is equal to.
Then we will compare MG and MGH.
Okay, that is fine. So GH is how much? What should I use? G into
1 minus 2 square.
Y?
Because it's 32 kilometers by 6,000.
Because the height is 32 kilometer only. 32 kilometer means it is close to the surface of the earth. So it is 1 minus 2H divided by R. Right. So what is going to be the weight at height H? Weight at H will be mgh. What is the weight on the surface? It is mg. What are they asking? You need to find the percentage decrease. What is the formula for percentage decrease? So can you tell me what is the formula for percentage decrease? It is actually final minus initial divided by initial. Am I right?
Yes, sir.
No, it is not right. I'm missing something.
Into
200 into 100.
Ah,
into 100.
yes. What I wrote is actually the fractional change. Right. So M will get cancelled. GH is how much? G into 1 minus 2H divided by R minus G, the whole divided by G into 100. So G will also get cancelled. 1 minus 2H divided by R minus 1 into 100. So 1 and 1 will get cancelled. Minus 2H divided by R into 100. Now tell me what are the values I need to substitute. Minus 2 into H is 32 divided by R is 6,400 into 100. Right. So 2 will cancel this 3,200 times. This will cancel this 100 times. This will get cancelled and you will be left out with 1. So what is the answer? 1%. So there will be a decrease of 1% in the value of G. Are you all getting a perspective of this? So the minus sign there indicates that there is a decrease in value, right? And how much is the decrease in value? It is 1%. Are you done? This is not good. So we'll do some problems based on variation of G with depth. Okay. So write down these formulae. problems based on variation of G with depth. Did you all finish writing it down? Okay, listen. So this is the question. Find the percentage decrease in weight of a body when taken. What is LB kilometer? I think it is 16 kilometer. When taken 16 kilometer below the surface of the earth. Find it out. So here also they are asking you the percentage decrease. So find out properly and tell me what is the answer.
Sir, half percentage.
Half a
0.5.
0.5. Check it again. The answer that I have says something else.
Sir, 1/4. 0.
It is 0.25%. Chitesh, check it. So what should I do? G at a depth D is equal to G into 1 minus D divided by R. Right. So this is equal to G into 1 minus what is the value of D? It is 16 divided by R is 6,400. This goes 400 times. So you will get 399 divided by 400 times G. Am I right? So we need to find the percentage decrease. So for percentage decrease, or for percentage change, what should I write? Final minus initial divided by initial into 100. So 399 by 400 G minus G, the whole divided by G into 100. So what will I get? Minus G divided by 400 divided by G into 100. G and G will get cancelled. 100. So minus 0.25%. So the percentage changes 0.25 and it has actually decreased. Right. Shall I proceed? Try this. How much below the surface of the Earth does the acceleration due to gravity become 1% of its value at the Earth's surface?
So can you show the previous slide?
previous slide.
Thank you, sir.
Yeah.
So 5670.
How much?
5670.
I don't want the answer. How much?
Oh,
Like, can you tell?
0.9 R.
0.9.
Um,
Check it. It's not 0.9. So what is the value of GD? What is the value of GD? It is, see, how much below? So what you need to find, D is equal to how much? So that the acceleration due to gravity becomes 1% of its value. So it is G divided by 100. That is 1%, no? So GD is equal to G into 1 minus D divided by R. Make sense? So G divided by 100 is equal to G into 1 minus, what is the value of D? That's what we need to find. D by R. G and G will get cancelled.
9.9.
9.9.
I think so.
9.9, no. D by R is equal to 1 minus 1 by 100. It is 99 by 100. It is 0.99, which implies D is equal to 0.99 times R. So almost after you travel, after you go to a depth of the radius, right, what will happen to the value of G? It will almost become 1% of its original value. That is the meaning. Are you all clear with this? So this will come out as 0.99 into 6,400 or 99 into 64. So 99 into 64, whatever is value, write it down. So 0.99 into 64, whatever is value, those many kilometers. Right, let me check what is the answer. Here it is 6336. 6336 kilometers. Okay. This is a good question. Try to do this. This is a good one. At what height above the Earth's surface, the value of G is the same as in a mine 80 kilometer deep. So what should we equate?
40 kilometers.
Very good. So GH should be equated to GD. For GH, what should you write? G into 80 kilometer is how much? It's actually a small value, though it is for the depth. The value in terms of height will be somewhat proportional to it. So since 80 and any other value will be less than the radius of the Earth, I need to use a formula. 1 minus 2h by r is equal to G into 1 minus D divided by r. G and G will get cancelled. 1 and 1 are gone. So 2h by r is equal to D by r. So R and R would also get cancelled, which implies H is equal to D by 2, which is 40 kilometer. I hope everyone is clear with this. Right? So did you all understand the concept of variation of acceleration due to gravity with altitude and depth? Right? Can I assume that this concept is understood by you all? Okay. So we'll move on to the next one. Okay. So these are all the formulae. I'll explain one by one. Listen to them. See, I explained one formula called as, like I explained one term called as gravitational field. You remember last class we discussed about gravitational field. So for every gravitational field, there is an intensity associated with it, which is called as the intensity of gravitational field. Okay. So in the intensity of gravitational field, it is defined like this. You calculate the amount of force and divide it with mass. So F divided by M is what is going to give you the gravitational field intensity. Okay, this is something you can just make a note of. It is defined as G into capital M divided by R square. Okay. Next. So we discussed the concept of gravitational potential. If you remember, gravitational potential is something similar to the electrostatic potential that we already know. So what is the formula for gravitational potential? It is the amount of work done per unit mass. So when you calculate it, the value comes out to be Gm divided by R. Then we discussed about the gravitational potential energy. So what is gravitational potential energy? It is actually gravitational potential multiplied with mass. Why is it so? Because U is equal to G capital M into small m divided by R, whereas V is equal to G into capital M divided by R. So what should I multiply? Sorry. So this I can write it as G into capital M divided by R into small m. But we know that G into capital M divided by R is potential. So it is potential into mass. So potential energy is equal to gravitational potential into mass. Okay. See, the fourth one, you don't need it as of now. That is called as potential gradient. That is not needed. Don't worry about it. So look at the fifth one. If there is a question that is asked, they're asking you about the total energy of a body in gravitational field, you need to write it as kinetic energy plus potential energy, which is nothing but half mv square plus negative of G into capital M into small m divided by R. Okay. Did you all make a note of all the formulae?
Yes, sir.
Good. Find the answer for this. Find the intensity of the gravitational field when the force of 100 Newton acts on a body of mass 10 kilogram in the gravitational field. It is very, very simple. So what is the formula for intensity of gravitational field? Oh, sorry, I showed the answer. So E is equal to F divided by M. What is the value of F? 100. What is the value of M? It is 10. Answer will be 10 Newton per kilogram. So it's 10 Newton per kilogram. Simple. So that's the value. Right. Now try this. Two bodies of mass 10 kilogram and 100 kilogram are at a distance of 1 meter apart. At what point on the line joining them will the gravitational field intensity be 0? So if you see, I'll solve this problem. I want you all to listen. There is a 10 kilogram mass here, 1000 kilogram mass here, which are separated by a distance of 1 meter. At which point on the line joining them will the gravitational field intensity be 0? Okay. Let's say that point P is here. Okay. If I take the distance from 10 kilogram mass to point P as x, then from P to 1000 kilogram will be 1 minus x. Am I right? So if you observe, field intensity due to the first charge should be equal to the field intensity due to the, not charge, sorry, mass. Field intensity due to the first mass should be equal to the field intensity due to the second mass, which implies what is the value of E1? Capital G into mass of the object divided by distance square. See, just to explain it again, listen. I use this formula, Gm divided by R square. Are you all able to understand? So capital G into mass divided by distance square. Okay, G into 10 divided by x square is equal to, can you tell me what is the gravitational intensity due to the second charge? G into 1000 divided by 1 minus x the whole square. So G and G will get cancelled. 10 will cancel 1000 100 times. So 1 minus x the whole square is equal to 100 times x square, which implies 1 plus x square minus 2x is equal to 100x square, which implies 99x square plus 2x minus 1 is equal to 0. So on solving this, we'll get the value of x. Okay. So I'm not expecting you to solve. If you have understood the concept, that is enough for me. Okay, that is one way. Or what we can do is from here, if you take square root on both sides, 1 minus x is equal to 100x, which implies 101x is equal to 1 also we can use. Sorry, not 100x, 10x. This 10x means 1 is equal to 11x, which implies x is equal to 1 divided by 11 meter. We can use this also. But I hope you could understand. Shall I proceed? Listen, guys. Okay, not necessary. Try this problem, but I'm making a small change in it. So three masses, each of mass m, are placed at the vertices of an equilateral triangle of side 1 meter. Okay, here it is 1 meter. What is the gravitational, instead of field, right? I'm going to ask you as what is the gravitational potential energy of the system and potential due to these three masses at the centroid. So there are two questions. First question is about gravitational potential energy of the system. And question number B is gravitational potential at centroid of the triangle. This is where we need to. Are you guys there?
Yes.
Yes.
Yeah. So tell me how to solve this problem. See, one point I would like to stress here is whenever they ask you a question based on gravitational potential energy, right? They need to use the word system. Whenever they ask you only gravitational potential, they will use the word at. Because gravitational potential is defined at a point, gravitational potential energy is defined for a system. Okay. Can you solve this? I'll be back in a minute. Sorry, my laptop got switched off. So did you all get the answer? What is the value of gravitational potential energy in that system? So what is the formula for gravitational potential energy? Can you tell me? Can you please confirm if I'm audible? I'm not getting any response. Aravind, am I audible?
Yes, sir, yes.
So what is the answer is what I'm asking for gravitational potential energy.
GM by R.
I'm asking the question nalla kelu. Gravitational potential energy ku what is the formula? I mean, what is the value? Hmm. Hmm. Yeah, what is the formula? Yesterday I told you so much. You guys also responded, no, for potential energy. I clearly mentioned what is the difference between both. What are they? So gravitational potential energy is minus G into M1, M2 divided by R. Right? What is the gravitational potential? What is the formula for gravitational potential? It is Gm divided by R. See, it is logic, okay? When in the previous class, when we discussed, we were discussing about the gravitational potential energy, where one of the objects was Earth. If it was not Earth, what will you do? You'll replace it with some other mass. I told you, no, gravitational potential energy is dependent on two mass. For you to calculate gravitational potential energy, you need two masses. Whereas for you to calculate gravitational potential, there is only one mass that is needed. Okay. So if you take 3-point masses which are placed at the vertices of an equilateral triangle, if this is M, this is also M, and this is also M, and if they are separated by distance R, okay, I take it as A, and A here. Okay, they're separated by this kind of thing. This is 1, 2, and 3. So how many masses are there? There are 3 masses, but the values are the same. So if I calculate the potential energy between the first and the second mass, what will it be? It will be minus G into M1 is M, M2 is also M, and what is the distance of separation between them? It is A. Similarly, what is U23? It is minus G into M1 into M2 divided by A. What is U13? Tell me. It is minus G into M divided by A. So all the three are the same. So if I want to find the total potential energy, I will write U is equal to I'll write U is equal to U12 plus U23 plus U13. Is there anyone who's not clear with what I wrote? You want me to explain it? I'll do it. Is there any doubt?
No, sir.
Okay, good. So what will you get? You will get minus 3 times Gm square divided by 8. This is going to be the value of the gravitational potential energy of this system. Am I clear to all?
Yes, sir.
Yes, sir.
Good. So first make a note of this. So whenever they ask a question of, please make a note of all these, the language that they are going to use. If they ask what is gravitational potential energy, I repeat it. If they ask what is gravitational potential energy, they will use the word system. Because gravitational potential energy cannot be calculated at a point. It can be calculated only for a system. Whereas gravitational potential is calculated at a point. So whenever they use the word gravitational potential, they use the word at something. In this case, it is at centroid of the triangle. Are you able to understand? So they will mention it clearly. You need to have that in your mind. I hope everybody made a note of it. Okay. Shall I proceed? So the second part of the problem is, gravitational potential at the centroid. So if this is M, this is M, and this is M. If I want to find the gravitational potential at the centroid, then what is going to happen? See, if I take this point to be G, what is the distance from the vertex to the centroid? This we have calculated in the when we did problems based on Newton's law of gravitation. Right. So tell me, what is the distance from the vertex to the centroid? Answer, I'm expecting. What is the distance, guys? What is the distance between the vertex and the centroid?
A by root 3.
It is A by root 3. Now you see, we need to calculate the gravitation. See, when I say potential, right, it means gravitational potential. Have that in mind. Potential at point G is how much? So if I take this to be the first charge, second charge, and third charge, it will be the potential due to the first charge plus potential due to the second charge plus potential due to the third charge. So what is the potential due to the first charge? It is G into mass of, I'm sorry, okay, I'm used to this word charge. So when I say charge, I'm talking about mass. Okay. So it is Gm divided by, what is the distance? Distance from the vertex to the centroid is A by root 3 plus G small m divided by A by root 3 plus G small m divided by A by root 3. So what will it be? It will be 3 times root 3 into Gm divided by A. Did you all understand this? So this is going to be the total potential at point G, where G is the centroid. Okay, don't get confused between this G and this G. Okay. So let me know if I'm clear.
Yes, sir.
Good. So this is one sort of problem that is based on gravitational potential and potential energy. Let me see if there is any other problem. Hmm. So do this one. Do this one. Find the potential energy of system of 4 particles, each of mass m, placed at the vertices of a square of 1 unit. Let me take it. Let's take it as of side A. Okay. Let it be of side A. Also, obtain the potential at the center of the square. Okay, do this. It's the same kind of approach. Okay. Find the potential energy of the system of 4 particles, each of mass m, placed at the vertices of a square of side A. So if I take this to be the first, second, third, and fourth. So before I start doing, did anyone get the answer for the potential energy of the system? So what
Minus 4 gm square by A.
minus?
4 gm square by A.
I expected this. That is only a part of the answer. I'll tell you what you missed. Okay. So U is equal to, for potential energy to be applied, how many charges are needed for you to apply that formula? How many masses are to be taken into consideration? Minus G, M1, M2. So there are 2 masses that are needed. So can I write this as potential energy between the first and the second charge? Observe the way I'm writing. Plus, can I write it as potential energy between the second and the third mass? Plus the potential energy between the third and the fourth mass, and the potential energy between the fourth and the first mass. Make sense? Is this what you wrote? Right. But I can also define the potential energy between the first and the third mass because they are diagonally opposite. Similarly, I can establish a relation for potential energy between the fourth and the second mass also. Am I clear with that? Now, if you
Yes,
see,
sir.
yes. So U12, U23, U34, U41, everything will have the same value of minus G into M square divided by A between them. But since they are coming 4 times, it will be minus 4 times GM square divided by A. Plus, what about this thing? It will be minus 2 times gm square divided by what is the distance between 1 and 3? It is
A by 2.
root 2a, no?
Okay.
So this will cancel this root 2 times. So answer will be minus gm square divided by a into 4 plus root 2. So this will be the value of the potential energy of the system. Clear with that? So this is the most important point. This is what we miss, this box. That should not be missed. Be careful with that. Okay. So what about the potential at the center of the sphere, center of the square? If I take the center of the square to be P, what is going to be the potential at the center of the square? Potential at the center of the square will be V1 plus V2 plus V3 plus V4. So what will it be? That will actually be 4 times V1. I will write only 4 here because for you to define the gravitational potential, how many masses are needed? Only one mass. Because what is the formula? G into M divided by R. So you need only one mass. So there are 4 masses. So I wrote it as 4 times V1. So this will be equal to 4 into, tell me what should I write? G into small m divided by, what is the distance between the first mass and point P? What is the distance between first mass and
A
point?
by root 2.
This time it is A by root 2. So this will be 4 root 2 times Gm divided by A. So I hope I'm clear. So now will you be able to handle the problems based on potential and the problems based on potential energy?
Yes, sir.
So are you guys ready to listen to a trick to identify how to write the correct formula? Shall I reveal it? See, listen to this. Listen to this. Here, how many masses did we have? 1, 2, 3, 4, right? So everybody is a math student here, right? Listen. So how many masses were there? Number of masses are 4. For writing the formula for gravitational potential energy, how many masses are supposed to be taken in combination? You need to take 2. So the expression for U will have a total of 6 terms in it. Did you have 6 terms? 1, 2, 3, 4. Did we have 6 terms? What were the 6 terms? U12, U23, U34, U41, U13 and U23, U24. Did we have them? We had 6 terms, no? But how to identify that 6 terms? That 6 is because it is 4C2. Where 4 is what? 4 is the number of masses. 2 is the fixed number. Okay. In a similar way, if I use a pentagon, then how many terms will be there in the expression for U? How many terms will be in the expression for U? It will be 5C2. Guys, are you there with me? Are you listening to it? So how many terms will be there? There will be 5C2 terms. Similarly, if I use a hexagon, tell me, you will have 6C2 terms. Whereas, when I write the expression for potential, then number of masses is equal to number of terms. Number of masses will be equal to the number of terms. That's it. So if there are 4 masses, there will be 4 terms. 5 masses, 5 terms. Like that, how many ever masses are there, you will have those many number of terms. Okay. Okay. So this is all for today. Then you have two more concepts that are escape velocity and orbital velocity, based on which you can try out the problems on your own, because it is direct application of formula, right? So everything related to gravitation, I have covered. Whatever problems are there based on principle of superposition, variation of acceleration due to gravity, gravitational potential energy, and gravitational potential. Okay. So I'm expecting for orbital velocity and escape velocity, you people do it on your own. Okay. So next week, I'll start off with the next volume. So bring your next, the second volume textbook. Clear? Shall we wind up?
Yes.
Shall we wind up? Okay, I'll see you guys.
Thank you, sir.
Thank you, sir.
Thank you, sir.